Yes, hi friends. In previous session, we are already discussing about introduction to OOAD, right? So in that session, we are mainly concentrating on what is OOAD and what is OOA process and what is OOD process, right? So simply, OOAD is a software engineering approach for modeling and designing the systems, as interacting the objects. So that is the basic definition for object-oriented analysis and design. Object-oriented analysis and design is a technical approach for analyzing and designing the objects by using object-oriented programming languages, right? So in addition to that, we are also discussing two more concepts. What is OOA process and what is OOD process, right? So OOA process takes functional requirements as an input, right? So it produces functional requirements results. So by that result is taken by OOD process. Simply it provides the implementation specification. So that is the basic concept, right? For OOA process as well as OOD process. So simply OOA process identifies the number of objects. So here objects are nothing but components, whatever it may be. So objects are also called as components or elements. So identify the objects, OOA process identifying the objects as well as describing the objects. So that is the main theme of OOA process. Fine. So then coming to what is OOD process. OOD process describing the objects and collaborating with another objects. Finally it produces some implementation specification to the next phase, that is implementation, coding phase or programming phase, right? So that is the basic concept of OOAD, right? So in this session we are mainly concentrating on one more concept, that is the structure of complex system, right? So in this concept we are mainly focusing on what is complexity and examples of complex systems. So here I am taking 4 real-time examples from different branches, right? So before going to this concept, first of all, what is complexity? So complexity depends number of objects in the system or number of components in the system, number of elements in the system, as well as number of relationships in the system. So we can evaluate the complexity of a system. So simply a system which contains limited number of objects or components or elements or relationships, then the system is said to be simple system. So coming to what is complex system. So complexity of a system depends on the number of systems. So if the system contains more number of components as well as more number of relationships, then the system is said to be complex system. For example, I am taking for suppose I want to maintain the one student application. So here system, application, business, both are same, all are same, right? So here I want to maintain the one student information. So that is simple system. Why? Because so it contains only one object, only one student. So here only one object, student name, student address, student mobile number. So that is limited number of relationships as well as object. So that's why that system is said to be simple system. So coming to complex system, if I want to maintain the entire college application. So our college contains more number of branches, right? So CSC, ECE, EEE, MEC, Civil, right? So each and every branch again divided into number of sections. So each and every section contains 60 number of students. So here the complexity level is increased. Why? Because so each class contains more and more number of objects. So that's why in such cases college application is said to be complex system. So simply a system which contains more objects and more relationships, then the system is said to be complex system. Otherwise the system is said to be simple system. So that is the basic theme of complex systems, right? So here I am writing what is complexity. What is complexity? What is complexity? Complexity depends on the number of components. Number of components or elements or objects, all are same. Remember that one, right? So complexity depends on the number of components in the system as well as relationships, and interacting between these components which carry difficult to design and test. Subject to change. Potentially inconsistent and incomplete. So complex systems are very difficult to design and difficult to test, as well as complex systems are dynamic in nature. So that's why once we can modify the objects, the entire relationships are also modified, right? So here complexity depends on the number of components in the system as well as relationships. So relationships are nothing but paths that connects the different components or different objects of the system, right? And interacting between these components which carry difficult to design and test, subject to change, potentially inconsistent and incomplete. So here I am considering complex system. So complex system, we can consider complex systems are dynamic in nature. For suppose I am considering our college system or college application. So after completion of first year, for suppose I am considering the CSE branch. So after completion of CSE first year, in second year, later entries also there, right? So we are also modifying the number of objects in the second year CSE, right? So that's why that is very difficult to design as well as difficult to test. So once we can change the objects, so that is inconsistent as well as incomplete system, right? So for suppose after completion of second year, some students are detained. So third year CSE system contains some limited objects only. So after detained, those roll numbers are removed by the application or system, right? So that is also dynamic in nature. So that's why complex systems are very difficult to design as well as difficult to test. As well as, so once we can change the number of objects in the system, so that system is said to be inconsistent and incomplete system. So this is about complexity of a system. So simple system. So if the system contains limited number of objects, limited number of relationships, then the system is said to be simple system. So here, more number of objects, more number of relationships. So that's why this system is said to be complex system, right? So here I am taking 4 real-time examples from 4 different branches, right? So here we are discussing examples of complex systems. Examples of complex systems. Examples of complex systems. So here I am taking 4 real-time examples from 4 different branches. So one example is taken from computer science, and one example is taken from biological sciences, and one example is taken from physical sciences, and one example is taken from normal social institutions, right? So these are the 4 real-time examples. I can consider 4 real-time examples to represent the complex systems. Fine. So here I'm listing the all examples related to complex system. So one is the structure of personal computer. The structure of personal computer, right? So our second example is the structure of plants. The structure of matter. The structure of matter. And final example is the structure of social institutions. So these are the 4 real-time examples for complex systems. Fine. So this example is taken from computer science branch. This example is taken from biological sciences, biology sciences. So especially botany. So plants, botany. So the structure of matter. So this example is taken from physics, physical sciences, physics. Physics. So the structure of social institutions. So this example is taken from the normal real-time example. So from various institutions, organizational institutions. So organizational institutions. Organizational institutions. Right? So these are the 4 real-time examples. So here we are discussing one by one. Right? So what is the first example? The structure of personal computer. So we know very well about what is the basic structure of computer. So it contains different elements. Right? So we are discussing about first example. The structure of personal computer. The structure of personal computer. So this example, so this structure can be considered as moderate complex system structure, right? So this is the best example for moderate. So not more number of objects, not limited objects, moderate objects as well as moderate components as well as moderate relationships are there. So that's why this example can be considered as moderate complex system structure. System structure. So what are the main elements and what are the major components in the personal computer? So we know very well about input devices, output devices, as well as CPU. So these are the major components that can be considered as personal computer structure, right? So input devices, output devices, CPU. Fine. So again input devices. So here several input devices are there. So we know very well about keyboard, mouse. So again these components can be decomposed into several objects. So complexity level is increased in level by level manner or hierarchical manner. So that's why this example is also considered as hierarchical complex system structure. Hierarchical complex system structure. So we know very well about hierarchical manner, level by level manner, right? So keyboard, mouse, joystick, trackball. Fine. What are the output devices? Monitor, printer. So these are the best examples for output devices. So coming to CPU, CPU again can be classified into 3 major parts: ALU, CU, then memory unit. Arithmetical logical unit, control unit, memory unit. So what is the main purpose of arithmetical logical unit? So it performs the arithmetical and logical operation which will dynamically carried out by computer, right? So here ALU is again made up of, so here ALU is made up of registers as well as random logic control. So again ALU component can be decomposed into two components, registers, random logic control. Again, so these registers can be made up of NAND gates as well as inverters. So again registers can be decomposed into two more components. So here we can represent or decompose the every component into level by level manner, hierarchical manner. So that's why this is the best example for moderate complex system structure as well as hierarchical complex system structure. Remember that one, right? So NAND gates as well as inverters. So coming to control unit. So control unit. So what is the main purpose of control unit? Control unit controls the all parts of information as well as coordinates the all parts of information. So that is the main purpose of control unit. So coming to memory unit. So memory unit can be divided into two types, primary memory, secondary memory. Primary memory, so memory unit can be divided into primary memory, secondary memory. So we know very well about these concepts. So these are the basic concepts for computer science students, right? So primary memory, secondary memory. Fine. So primary memory again classified into different components like RAM, ROM. Secondary memory again classified into CD, DVD, hard disk device drives. So those are the best examples for primary memory as well as secondary memory components, right? So so here we can decompose the entire system structure into number of components. So again those components can be divided into again and again. We can represent the entire system in hierarchical manner. So that's why this is the best example for moderate complex system structure as well as hierarchical complex system structure or hierarchical in nature. So this example is hierarchical in nature. So what is the another example? So here I am taking one more example from biological sciences. So the structure of, what is the second example? The structure of plants. The structure of plants. So this is the best example to represent the complex system. So this is more complex system structure in nature, right? So this is not moderate complex system structure, right? So here each and every plant contains three structures. Roots, stems, leaves. Root, stems, leaves, right? So again, so here roots, what is the main purpose of roots? So here the structure may vary from one plant to another plant also. So all plant structures are not same. So vary. So vary can be studied through one more branch, that is morphology. So plant different formations, different structures of plants can be studied through one branch, that is morphology. So morphology. So what is the meaning of morphology? So morphology is coming from morpho and logos. So what is the meaning of morpho? Different forms or different structures of plants. So morpho, simply it represents form. Logos means studies. So various structures of plants can be discussed or studied through morphology. So morphology comes from morpho. So morpho means form, logos means studies, right? So here I am taking some basic structure for plant, right? So here this majorly plant contains three structures. One is root, stems, leaves, right? So roots are responsible for taking the water. So roots are responsible for taking the water and minerals from the soil. So this is the major responsibility of roots. Coming to second component or second structure, that is stems. So here we are considering component, structure, system, business, application, all are same. Remember that one, right? So stems. So stems are interacting with roots and observing water and minerals from roots and pass it to leaves. So what is the major responsibility of leaves? So leaves. So leaves are responsible for preparing food. Roots are responsible for preparing the food by observing the minerals and water provided by the system, as well as, so here one system is there to preparing food, photosynthesis. So by using photosynthesis, leaves prepares food. So by using this system, so provided by the system, as well as using photosynthesis. So again, roots, stems, leaves contains some elements, cytoplasm, chloroplasts, right? So cytokinins, mitochondrions, so different elements are there. So again, this root can be divided into several components, right? So these are the major responsibilities of plants. So here this system also dividing several components as well as